Hello students, this is the third video uh, on normal distributions. So let us continue with the worksheet. Now it's 14th problem of the worksheet. The weights of a group of children are normally distributed with a mean of 22.5 kilograms and a standard deviation of 2.2. So mu is 22.5 and sigma is 2.2. Right. Now the first subdivision is A. Write down the probability that a child selected at random has a weight more than 25.8 kilograms. So probability of selecting a student whose weight is more than 25.8. This can be easily found using the calculator. So go to distribution, normal, go to NCD, and then so I want more than 25.8. So the least value is 25.8. So the lower limit is 25.8 and the upper limit is 10,000 and sigma is 2.2, mean is 22.5. So the answer is 0.0668. So 0.067, three significant figures. Second part is, of the group 95% weigh less than k kilograms. Find the value of k. So probability of x less than k equal to 95%, which is 0.95. Probability of x less than 0.95. The diagram below shows a normal curve. Okay. I'm sorry. Okay. Now we need to find the value of k first. So how do you do it? Now area is given. We need to find the value of k. So obviously you have to use inverse normal. So if you imagine the shaded part here, we can see that it is less than k, right? So tail is on the left hand side. So go to distribution of the normal, inverse normal. The tail is left. The area is 0.95. So you'll get k as 26.11. So 26.1. Yeah. Finally, the third subdivision. There's a diagram given. It's a diagram. On this diagram, shade the region that represents the following information. 87% of the children weigh less than 25 kilograms. 87% of the children weigh less than 25 kilograms. We need to represent this information in this standard normal diagram. So what we do is, first I'll draw the mean, which is 22.5. So 22.5. Then I'll mark 25. So this is 25. So I will mark this. So this area less than 25 kilograms. This area is actually 0.87, 87%, so 0.87. So this is the answer. Fine. I hope you understand how to do this problem. Let's go to the next problem now. In a large school, the heights of all 14-year-old students are measured. The heights of the girls are normally distributed with mean 155 centimeter and standard deviation 10. So for girls, mu is 155 centimeters, so I'll write 155, and standard deviation is 10. Now for the boys, mean is 160 centimeter heights of the boys, and the standard deviation is 12. Fine. The first subdivision, find the probability that a girl is taller than 170. So P of x more than 170. This is for the girls. So what I'll do is distribution normal NCD. Now lower limit is 170, upper limit is 10,000, sigma is 10, mu is 155. So it is 0.067. So 0.067. Now the second part is given that 10% of the girls are shorter than x centimeter. So probability of Ax less than x equal to 0.10. So 10% of them are shorter than x centimeter. Find the value of x. So it is inverse normal. Less than x means the tail will be on the left hand side. So go to distribution normal, inverse normal. Left area is 0.1. Sigma is 10 and mu is 155. So x is 142.18. So 142.18 approximately. So 142 if correct to three significant figures. Now the third part, C. Given that 90% of the boys have heights between Q and R, where Q and R are symmetrical about 160 centimeter and Q is less than R, find the value of Q and of R. Okay, so I think let me draw the diagram that will make it easier to solve this problem. So this is the x-axis and this is the normal diagram. I'll draw the mean here, which is 160. It is mentioned that Q and R are symmetrical about 160 with Q less than R. So that means I'll take, so this is Q and this is R, and it is given that this area in between Q and R this is 90%. This is 90%. That means 0.9. So obviously it means that this will be 0.45 and this will be 0.45. So the question is find the value of Q and of R. So which means this is 0.05 and this is 0.05. So I'll get two equations. The first one is P of y, maybe for boys I'll take it as y. P of y more than R is 0.05. So find the value of R. So you can use inverse normal, distribution normal, inverse normal. The tail is right now, right? Y greater than R. So right hand side, the tail is right. The area is 0.05. Sigma is 12 now because we are finding for the boys, and mean is 160. So R is 179.7. So it is approximately 180 centimeters. Same way here I can write P of x less than Q is 0.05, isn't it? In fact, we can, since we have found R as 180, this is 180, that means this, if R is 180, this will be 20, right? So definitely the value of Q will be, so this will also be 20, so Q will be 140. Let us verify that. So go to distribution normal, inverse normal, tail is left, area is this 0.05, and you get Q as 140.26. So 140.26, so approximately 140. Yeah, that's the value of Q. Fine. Now the next part is, in the group of 14-year-old students, 60% are girls and 40% are boys. So girls 60% and there are 40% of boys in a group of 14-year-old students. Now the probability that a girl is taller than 170 centimeter was found in part A. So this is it. The probability of a girl being taller than, selecting a girl who is taller than 170 is 0.067. Now for the same thing for a boy is probability of y greater than 170 is given as 0.202. Now a 14-year-old student is selected at random. So calculate the probability that the student is taller than 170 centimeter. So a 14-year student is selected at random. What is the probability that the student is taller than 170 centimeter? Now there are two possibilities, right? I can select a boy or I can select a girl, right? So probability of selecting a boy is 40 by 100, and the probability that boy's height will be more than 170 is 0.202. Or I can select a girl, right? So 60 by 100, and probability of her being more than 170 centimeter is 0.067. Fine, you can use a calculator to find this answer. And the last part is, given that the student is taller than 170 centimeter, what is the probability that the student is a girl? Okay, so what I'll do is I'll erase this. So I want to find P of selecting a girl. Okay, I'll just write it as P of girl, given that the student is taller than 170 centimeters. So the student is taller than 170 centimeter, right? This is what I have to find. So using the formula, I'll get P of girl intersection and taller than 170 divided by P of taller than 170. Now, so numerator will be, that means selecting a girl, 0.60 multiplied with the 0.067 was it? A girl being taller than 170 centimeter divided by, now whatever answer we found in D, just put it here, right? P of selecting a taller student, taller than 170 centimeter, that you can substitute here and find the answer. So that's all. You'll get the final answer. Fine. Let us look at the 16th problem. The heights of a group of students are normally distributed with mean of 160 and a standard deviation of 20. So mean 160 and standard deviation is 20. So the first part, a student is chosen at random. Find the probability that the student's height is greater than 180. So P of x more than 180. So it's quite easy to find. Go to NCD. more than 180 means the lower is 180, upper limit is 10,000, sigma is 20, and mean is 160. So the answer is 0.1586, so 0.159. Yeah. And the second part is, in this group of students, 11.9 percentage have heights less than d. So probability that the height is less than d is 11.9%, so 0.119. Find the value of d. So obviously you have to use inverse normal. Tail is left, area is 0.119. You'll get d as 136.399. So approximately 137. I'm sorry, 130, not 137, it is 136. 136 approximately. Right? 17th problem. The weights of chickens for a sale in a shop are normally distributed with mean 2.5 and standard deviation is 0.3. So mean is 2.5 and standard deviation 0.3. A chicken is chosen at random. Find the probability that it weighs less than 2 kilograms. So P of X less than 2. Now that you can easily find it using the calculator. And the second part is, what is the probability that it weighs more than 2.8? So P of X more than 2.8. Okay. Now let me find the answers. So distribution normal, NCD. First, let me find P of X less than 2. That means the lower limit is minus 10,000. The upper limit is 2. Sigma is 0.3 and mu is 2.5. So you get 0.0477. So 0.048. And for the second one, you need more than 2.8. So the lower is 2.8 and the upper is 10,000. So you get 0.1586, so 0.159. Now there is a diagram given here. The diagram. This is given. This is 2.5, the mean. Copy the diagram below. Shade the areas that represent the probabilities from parts 1 and 2. That means this 0.048 and 0.159. We need to represent them in this diagram. Okay. So I'll take, so this is 2 and this is 2.8. I'll draw a line here. So this is actually, this is 0.159 and this area is 0.048. That's it. Fine. Now the second part is, a customer buys 10 chickens. Find the probability that all 10 chickens weigh between 2 and 2.8. Okay. Between 2 and 2.8. So this is 2.8. Now, how do we find this area, student? How do you find between 2 and 2.5? 2.8, sorry. 2 and 2.8. Quite simple. The total area is 1. So I'll write 1 minus 0.048 plus 0.159. So which will give me 0.793. Yeah. So this area is 0.793. Now a customer buys 10 chickens. Find the probability that all 10 chickens weigh between 2 and 2.8. So the answer is, so the B, first part, the answer is 0.793 raised to 10. Not multiplied with 10, but power 10. Yeah. Now the final question is slightly difficult. It's mentioned that find the probability that now a customer buys 10 chickens, isn't it? He's buying 10 chickens. Find the probability that at least 7 of the chickens weigh between 2 kilograms and 2.8. So that means either 7 chickens weigh between 2 and 2.8, or 8 or 9, or all 10 chickens weigh between 2 and 2.8. So here 7, 8, 9 and 10, right? So definitely we can use the concept of binomial distribution. Yeah. So what you do is, here n is 10, the number of trials is 10. Now success is selecting a chicken whose weight is between 2 and 2.8, right? So definitely then P will be, probability of success will be 0.793. So I want to find probability of X greater than or equal to 7, at least 7 chickens. So 7, 8, 9 or 10. So I can write it as, so 1 minus P of X less than or equal to 6. Now go to distribution, statistics, distribution, go to binomial, and you need to enter BCD now, right? X is 6, I want less than or equal to, so say X is 6, number of trials is 10, probability of success is 0.793. So you'll get 0.134, 1335, so 0.134. So the final answer is 0.866. So the probability that at least 7 of the chickens will weigh between 2 kilograms and 2.8 kilograms is 0.866. Fine. Students, the 18th problem is actually very similar to problem number 12, right? So that was solved in the second video. So you can go through it and then you'll understand how to solve the 18th problem also, right? So let me just write the first few steps if you want. So it's given that the heights of certain flowers follow a normal distribution. It is known that 20% of these flowers have a height less than 3 centimeter. So P of X less than 3 is 20%, so 0.2, and 10% have a height greater than 8. So P of X greater than 8 is 10%, right? So you need to find the value of mu and of sigma. So what you do is you convert this into Z. So P of X minus mu by sigma less than 3 minus mu by sigma equal to 0.2. So P of Z less than 3 minus mu by sigma equal to 0.2. Same way here, P of X minus mu by sigma is greater than 8 minus mu by sigma 0.10. So P of Z more than 8 minus mu by sigma equal to 0.10. So what you can do is, here you can use inverse normal. This is the area, the tail is left, and using that and sigma is 1 and mu is 0. So 3 minus mu by sigma, you will get an answer. Same way here, you can use inverse normal and you will find the value of this, and then you will get two equations in two variables, and then you can solve it, right? It's quite simple. And I think the 19th is also again the same, finding mu and sigma, so please solve it on your own. We are going to see the 20th problem now, students. Fine. Residents of a small town have savings which are normally distributed with a mean of $3,000 and a standard deviation of $500. So mu is 3,000 and standard deviation is 500. Okay. And the question is, what percentage of townspeople have savings greater than $3,200? So P of X greater than 3,200 is equal to, so if you use a calculator, you'll get 0.3446. So the answer is around 34.5%. The answer is 34.5% of townspeople have savings greater than 3,200. Now, two townspeople, second one is two townspeople are chosen at random. What is the probability that both of them have savings between 2,300 and 3,300? So first let me find P of X more than 2,300 and less than 3,300. Let me find this probability. So if you use the calculator, lower is 2,300, upper is 3,000. Lower is 2,300, upper is 3,300. You'll get 0.645 as the answer. Now, what this means is probability of selecting a person or one townspeople whose savings is between 2,300 and $3,300 is 0.645. Selecting one person. Now we are selecting two townspeople, and what is the probability that both of them have savings between 2,300 and 3,300? So the answer is 0.645 multiplied with 0.645. The first person should have savings between 2,300 and 3,300, and so multiplication. The second person should also have savings between 2,300 and 3,300. Yeah. Finally, the last sum. The percentage of townspeople with savings less than $D is 74.22. So probability of the savings less than D is 74.22. So 0.7422. Find the value of T. You can use the inverse normal option. The tail is left, area is 0.722. So you'll get D as 3325.07. So approximately 3325. Yeah. Fine. Yeah. I'm not going to solve 21st problem, students. It's quite simple. By now, if you have watched the previous two videos and if you've been watching this video, it will be quite clear to you as to how to solve that problem. So I'm not going to solve it. So let us go to 22nd problem. It's given that reaction times of human beings are normally distributed with the mean of 0.76 seconds and a standard deviation of 0.06. So mu is 0.76 and standard deviation of 0.06. Okay, now there's a graph here. So I draw here. This is the standard normal curve. This is 0. Here we have B and here we have A. And this part is shaded. Fine. Now it's given that the graph below is that of a standard normal curve. The shaded area represents the probability that the reaction time of a person chosen at random is between 0.70 and 0.79 seconds. Okay, that means this is the probability that the reaction time of a person chosen at random is between 0.70 and 0.79 seconds. So find the values of A and B. That means this A corresponds to 0.70 and B corresponds to 0.79. Now how do we find it? Very simple. So this is actually X value and A and B are Z value. So we know that A is X, we know that Z is X minus mu by sigma, right? So same way, we know that A will be equal to 0.70 minus mu, that is 0.06 by sigma. I'm sorry, mu is 0.76, right? So mu is 0.76 by 0.06, right? And similarly, B is 0.79 minus 0.76 divided by 0.06. So if you use your calculator, you will get these answers. So minus 1 and you will get 0.5, which is half. So A is minus 1 and B is half, right? Fine. Now the second part is calculate the probability that the reaction time of a person chosen at random is greater than 0.70. So P of X more than 0.70. Now how do you find it? You can easily go to use a calculator to find the answer. You know, mean is given, standard deviation is given. You can use NCD. The lower limit is 0.70, upper limit is 10,000, and you will get the answer. Similarly, you can also find the answer for B, which is probability that X is between 0.70 and 0.79. So lower limit is 0.70, upper limit is 0.79. Quite easy problem. Final one is the last two questions are 3% of the population have a reaction time less than 3 seconds. Okay, represent this information on a diagram similar to the one above. That means I have to represent this in a standard normal curve diagram. So this is the standard normal curve. This is 0. 3% of people, population, have a reaction time less than C. So I have C here. So this is 0.03. So probability of X less than C is 0.03, 3%, 0.03. Find the value of C. Again, it's quite simple. Go to statistics, distribution normal, inverse normal. The tail is left, area is 0.03, sigma is 0.06 and mean is 0.76. So we'll get CS, the value of C will be 0.647. I'm sorry, it is now you may be wondering, what is this? C is less than 0, so won't it be a negative number? No. Actually, we're talking about C for the original data, original problem, where sigma is 0.06 and the mean is 0.76. So the answer is 0.647. If you feel it is confusing, then you can just ignore. You can just erase this 0 and C. So this is fine. Yeah, no need to worry about it. So this is the answer. Okay, fine students, I think that's enough for this video. It's already 35 minutes. So what I'll do is the final, I think there are around 6 more problems. I'll do it in the one more video, the 4th video. So thanks for watching this video.